Welcome to Canerica's podcast, The Digital Shift.
Thanks for having me. Today we're doing a really essential deep dive.
We are.
We're pulling back the curtain on something critical, often kind of unseen. The infrastructure that powers basically every modern company. Data engineering tools.
Yeah, this is the stuff behind the scenes.
Exactly. Think of this as your high-impact shortcut, to getting up to speed on it all.
That's a great way to put it. I mean, This is the infrastructure discussion that really decides who wins and who loses in the market today. Just to kick off with a huge implication. Think about a platform like Airbnb. Massive scale, right?
Huge.
Millions of bookings daily, over 220 countries. How did they do real-time pricing, custom recommendations, instant fraud prevention?
It all comes down to the data engineering.
Completely. It hinges entirely on having the right infrastructure in place. Systems that can handle that global scale, that instant response.
And the problem these tools solve, it sounds complex, but fundamentally it's quite simple. Every single organization, including yours listening right now, generates just terabytes of data. Customer clicks, transactions, logs, every second.
It's an avalanche.
It really is. But without the proper tools, this incredibly valuable information just sits there. It's siloed, isolated.
Which slows everything down.
Totally. It slows down decision-making. It holds back growth.
Yeah.
So today, we're here to unpack the systems that, solve this information crisis.
Okay, so our mission today is pretty straightforward. We want to give you an impactful, high-level view.
Yep, the big picture.
The strategic categories, the business implications, the core choices you face with these tools. We want you to leave this deep dive feeling well-informed, ready to talk about data strategy.
Without getting totally bogged down in every single technical specification.
Exactly. So, okay, let's unpack this then. Before we jump into the tools themselves, maybe let's establish why. Why are these systems just, non-negotiable now for the bottom line?
It really starts with scale, doesn't it? The sheer volume.
The data volume explosion.
Yeah, and it's unavoidable, the common estimate. Global data creation is growing something like 23% every single year.
That's staggering.
It is. And frankly, the old ways, the traditional manual processes, those custom scripts, basic transfers that always seem to break Tuesday morning.
Oh, I remember those days.
We all do.
Yeah.
They just cannot handle this kind of velocity and volume anymore. It's impossible.
And it's not just the amount of data, right? It's the speed expectation.
Ah, yes. Real-time requirements. Data velocity.
Customers just demand instant responses now. Think e-commerce recommendations, or even more critical, like fraud detection.
Things that need processing in seconds.
Exactly. Seconds, not hours or days. And streaming tools are pretty much the only way to enable that kind of instant response, to keep that competitive edge.
And beyond just staying competitive, there's a big financial angle here, too. Cost control. Efficiency.
How so?
Well, doing this manually is super resource intensive. It's fragile. You often need highly paid engineers just babysitting systems that are, likely to break. Automated data engineering tools. Studies show they can cut processing costs by, say, up to 40%.
40%? That's huge.
It is. And at the same time, they massively increase the reliability of your pipelines. No more, hopefully, of those 3 a.m. calls when some ancient script finally gives up.
We've all been there. That relatability is key. And look, if you needed more convincing, there's competitive advantage in compliance, too.
Absolutely. Organizations that can get insights from their data faster, they just have a speed advantage. Faster time to market for new features, new products.
And the compliance piece.
Oh, that's huge. Enterprise data tools are basically mandatory now for compliance. They have built-in security, detailed audit trails, the encryption needed for regulations like GDPR.
The General Data Protection Regulation, yeah, specific controls needed there.
Exactly. And that level of reliable, documented compliance, you just can't guarantee that consistently with manual processes. It's too risky.
Okay, so the why is crystal clear. Survival, growth, speed, efficiency, compliance, it all demands this stuff.
Pretty much.
So how is it actually engineered? How do we meet these massive requirements? We need to look under the hood a bit, right, at the structure of the modern data pipeline.
Exactly. And to understand how these systems deliver all that value, we usually break data engineering down into, let's say, 5 core categories.
5 core jobs these platforms do.
Yeah, that cover the whole data journey, from where it starts right through to where it gets used for analytics.
Okay, let's start at the beginning then. Category 1, data ingestion and streaming. You mentioned change data capture, CDC, earlier as key. For anyone listening who isn't familiar, why is tracking only the changes so important for real time?
Ah, CDC. It's all about efficiency, really. Its job is moving data from all sorts of sources to destinations, often in real time.
Right.
But the key is, it only sends the updates, the changes, as they happen, not the whole massive database every time.
Which saves a ton of resources.
A huge amount. Network bandwidth, load on your production systems, it minimizes all that. And it's what makes true real-time reporting actually feasible. It's kind of the linchpin for these modern instant pipelines.
Makes sense. Okay, next up, category 2, data processing and transformation. This is where the raw stuff gets cleaned up, reshaped, analyzed.
Yeah, where the magic happens, you could say.
And the key function here is distributed computing. What does that let data teams do? That's scalability.
Distributed computing, it basically lets the system spread the workload automatically across potentially hundreds, even thousands of relatively inexpensive servers.
So you're not limited by one machine?
Not at all. You can process terabytes of data all at once, in minutes sometimes. Workloads that would just completely crash a traditional single-server setup. It's really the engine driving big data analytics.
Okay, then we need someone to direct all this traffic. Category 3, workflow orchestration.
The traffic cop, yeah.
Scheduling, managing these complex pipelines. And the key function is dependency management. Why is getting that order exactly right so critical?
Well, think about it. If a transformation job tries to run before the ingestion job that feeds it is actually finished.
You get bad data or no data.
Exactly. Incomplete data, missing data, cascading errors all the way down the line. Orchestration tools manage those dependencies meticulously. And they also handle automated error recovery, retries, alerts when things fail.
So the whole system stays reliable.
That's the goal.
Yeah.
Even if one little piece hiccups, the orchestrator keeps things on track.
Got it. Category 4, data storage and warehousing. This is where the clean process information lives, ready for analysts or dashboards. Optimized for analytics, you said?
Highly optimized.
What makes them so fast for those kinds of analytical queries?
It really comes down to the architecture. Two key things usually. Elastic scaling, so it can grow or shrink resources as node, and columnar storage.
Columnar storage, how's that different?
So unlike traditional databases that store data row by row, columnar storage stacks data vertically by column, which makes it incredibly fast to scan just the specific columns you need for an analytical query, like, say, calculating total sales, without having to read loads of irrelevant data from other columns in the same rows.
Wow.
Much faster for analytics.
Clever. Okay, finally, category 5, data quality and monitoring, making sure the data is accurate and the pipeline itself is healthy.
Absolutely fundamental.
Key function, continuous data validation.
Right. Because if you can't trust the data, the insights are worthless, aren't they?
True.
So continuous validation applies automated rules. It's constantly checking for format errors, missing values, outliers, things like that. And crucially, there are immediate alert systems.
So you know right away if something's wrong.
Exactly. Teams get notified the second a problem pops up, often before that bad data even has a chance to pollute a critical business report or a machine learning model.
Okay, these 5 categories make sense. Ingestion, processing, orchestration, storage, quality. But here's where it gets really interesting, right?
Yeah.
Managing all 5 simultaneously, making sure the handoffs are smooth, no data gets lost, ensuring everything's compatible. That sounds like the hardest part.
Right.
Requires real expertise.
That is exactly the challenge. Integrating these 5 stages smoothly, making it all work together reliably and efficiently, that's the tough bit.
Right.
It's where deep expertise in things like, say, data governance, or knowing how to prep data for AI and ML becomes absolutely critical. You need to ensure the pipeline doesn't just run, but that it's trustworthy, secure, and actually ready for those advanced applications.
Makes sense.
And, as we at Canerica understand this complexity intimately, our focus is really on delivering those advanced end-to-end data engineering solutions.
Right.
We leverage our core strengths in AML, data governance, data integration to transform that raw, messy information into clear, actionable insights for you. And because we're certified partners with key players, folks like Microsoft and Databricks, the solutions we design deliver that accuracy, speed, and strategic scalability you need from the first byte ingested to the final insight.
That integration expertise is key. Okay, so let's look at some of the actual platforms winning across these categories. We can't dive super deep into all of them, but maybe highlight a few that really exemplify modern capabilities. Breadth over depth here.
Sounds good. Starting with the big unified platforms, you've really got 2 giants, Microsoft Fabric and Databricks.
Okay, Microsoft Fabric, what's the headline there?
Fabric's big play is its unified workspace. It brings together data integration, warehousing, BI, even AI capabilities like Copilot assistants, all into one place.
So simplifying the tool chain.
Massively. It's often the natural choice for organizations already heavily invested in the Microsoft 365 or Azure ecosystem. It just fits right in.
Okay, and contrasting that with Databricks.
Databricks, well, it grew out of Apache Spark, so its roots are strong in processing, especially for machine learning and data science workloads. That's often seen as its core strength.
And key features people talk about.
Two big ones. The Unity catalog for centralized governance across your data assets, and critically, Delta Lake.
Delta Lake, we hear that a lot. Why is it such a strategic differentiator for them?
Delta Lake. It effectively bridges the gap between, let's say, the flexibility of a raw data lake and the reliability you need for enterprise data warehousing.
How does it do that?
It provides A-side transactions, that's atomicity, consistency, isolation, durability. It's basically the industry standard guarantee for data integrity, ensuring your data stays consistent even with lots of simultaneous updates or system hiccups.
So it makes your data lake trustworthy for critical stuff.
Exactly. Trustworthy enough for financial reporting, for critical ML model training, things that demand absolute data integrity. It's a game changer for data lakes.
Okay, moving to pure processing power. Apache Spark and Apache Kafka often dominate the open source conversation here. Spark, known for in-memory computing.
Yes, precisely. And that in-memory approach is what gives it its speed. It can be up to, 100 times faster than older disk-based systems like Hadoop MapReduce, making it fantastic for technical teams who need that raw power and flexibility for complex data manipulations on massive data sets.
And Apache Kafka, crucial for real-time.
Absolutely crucial for real-time. It's built as a high-throughput distributed streaming platform. It can handle millions, literally millions, of messages or events per second.
So if you're building, say, a microservices architecture.
Kafka is often the bedrock. If you need reliable, high-volume, instant event streaming between different parts of your application, Kafka is usually the go-to standard.
Okay, final category spotlight, warehousing and transformation. Snowflake gets a lot of attention.
It does. Snowflake really pioneered the cloud-native data warehouse model.
What's its claim to fame?
The big one is separating storage and compute. This allows you to scale them independently, which is very efficient. You pay for compute only when you're running queries.
And features like automatic scaling, zero-copy cloning.
Yep. Exactly. Zero-copy cloning is fantastic for development. And testing instantly create a full copy of your production data without actually duplicating the storage. It's ideal for teams that prefer standard SQL and like that clear, usage-based pricing model without managing infrastructure.
And then there's DBT Data Build Tool. This one feels a bit different.
It is different, yeah.
Yeah.
DBT isn't the database itself. It brings software engineering best practices to the transformation layer within your warehouse.
How so?
It lets analysts and engineers define data transformations using just SQL, but then it adds things like version control, automated testing, and documentation generation on top.
So making the data modeling process more robust and reliable.
Fundamentally transforming it, yes. It brings discipline and engineering rigor to how you build and maintain your core data models. Very popular in the modern data stack.
Okay, that's a great overview of some key players. Now, the big question for listeners, what does this all mean for you when you're trying to choose?
Right, this is critical. The key insight here is that there really is no single best tool or stack for everyone.
It depends.
It totally depends. Choosing the right setup requires a really systematic look at your own specific business reality, your needs, your constraints.
So what are the main criteria you should use for that assessment?
I'd say there are three main pillars to consider. First is scale and team expertise.
Okay. How does team size factor in?
Hugely. If you have a small data team, maybe 1 to 5 people, you should probably lean heavily towards managed SaaS solutions. Think tools like Fivetran for ingestion, Snowflake for warehousing.
Why? Less maintenance overhead.
Exactly. Minimize the time your small team spends just keeping the lights on. Let them focus on delivering value. On the flip side, data volume. If you're consistently dealing with, say, over 100 terabytes, maybe petabytes,
You need something beefier.
you absolutely need distributed systems designed for horizontal scaling, like Spark or Databricks. You just can't keep vertically scaling a single database instance indefinitely.
Right. Okay. Second criterion.
Ecosystem fit and compatibility. Where does this new tool fit with what you already have?
The modern data stack combo you mentioned. Fivetran, Snowflake, DBT, Airflow.
Yeah, that combination has become popular precisely because those tools are designed to work well together. It provides proven compatibility, which can dramatically reduce integration headaches and complexity.
Makes sense. And existing cloud investments matter too, right?
Absolutely. If your organization is already deeply invested in AWS, looking at AWS's own services like Redshift for warehousing or Glue for ETL often makes sense. Same for Google Cloud users. BigQuery's serverless model is often a major draw there. You want synergy, not friction.
Okay, makes sense. And the third criterion, always a big one.
Budget and total cost of ownership, TCO.
Right. Now, hold on. A lot of teams look at open source tools like Spark or Airflow because they're free, no license costs.
They're free to acquire, yes, that's the hook.
But you're saying the TCO might not actually be lower?
Often it isn't, or sometimes it's even higher in the long run. That free open source software requires significant investment in highly skilled, usually highly paid, engineers.
For setup, maintenance, scaling, patching.
All of that. Constant care and feeding. Managed services like Snowflake or Fabric, yes, they have upfront license or usage costs, but they drastically reduce that ongoing operational overhead.
Allowing your team to focus elsewhere.
Precisely. On delivering business value, building models, creating insights, not patching servers at 2 a.m. That hidden operational cost is often the killer in TCO calculations for open source. You must factor it in.
That's a crucial distinction. Okay, so gaining this knowledge, understanding the tools, the criteria, that's a vital first step. But actually doing it, moving from that strategy on paper to a working deployment.
That's where the real challenge often lies.
Managing the cloud costs, integrating security correctly, planning for scale, handling failures, it gets complex fast.
It really does. And this is precisely where we at Canarica often step in to help organizations.
Right.
As a premier data and AI solutions company, and being a trusted partner with both Databricks and Microsoft for their data and AI solutions, well, we bring that proven implementation expertise to the table.
Connecting the strategy to the reality.
Exactly. We help connect your strategic choices directly to the right platforms, whether it's Microsoft Fabric, Databricks, Power BI, or others. Our goal is to enable your organization to unlock the full potential of modern analytics, drive that growth and innovation you're after, but, without the deployment headaches and pitfalls.
That expertise makes all the difference. Well, thank you for joining this deep dive into the really critical world of data engineering tools. We covered a lot of ground.
We certainly did, from why it's essential through the core categories, key tools, and how to choose.
We focused a lot on the volume, the sheer amount of data, and the need for speed driving the adoption of these tools.
That's right. Those are often the most immediate pressures businesses feel.
But as our listeners reflect on their own data strategy, maybe there's a final thought, something else they should keep in mind.
Yeah, there is. We talked volume and velocity, the two big Vs. But data engineers constantly grapple with two other Vs that are just as crucial: variety and veracity.
Variety and veracity. Explain those quickly.
Variety is the challenge of dealing with all the different types of data-structured tables, unstructured text, images, logs, streaming data, all coming from different sources in different formats. Integrating that variety is tough.
And veracity.
Veracity, it's all about the trustworthiness of the data. Its accuracy, its reliability, its quality. You can have all the volume and velocity in the world, but if the data itself is wrong or inconsistent, your insights will be flawed, maybe even dangerously flawed.
So it's not enough just to handle speed and scale?
Not at all. Ensuring all four Vs, volume, velocity, variety, and veracity, are handled properly and consistently. That's the real difference between just having a lot of data and having trustworthy, actionable business intelligence. Definitely something to explore further on your own.